I'm going to start babbling as people drift in. I know it's a couple minutes before class officially starts, but I want to save a lot of time for review. But this article came out this week, and I wanted to mention it for entertainment value. So this is from the New England Journal of Medicine, which is probably the premier medical journal in the U.S., up there with the Journal of the American Medical Association, JAMA. Some people call this the New England Journal of Positive Results because things get published if they're positive results, and otherwise they don't get. Anyway, this is a study of variation in hospital mortality for people who have inpatient surgery. And there's a huge amount of data, 84,730 patients. You can see here, oops, I can't quite highlight. They went to great pains to ensure that data reporting was accurate, but this is actually what is entertaining to me. I've read the article. I haven't completely digested the analysis they did, but the main claim is that if you look at the rate of complications, of surgical complications, you look at sort of minor complications and major complications, and you look at hospitals that had relatively low mortality from surgical complications and hospitals that had relatively high mortality from surgical complications, you find that the rate of minor complications was about the same in both groups. The rate of major complications was about the same in both groups. But the mortality from the major complications was much higher in the hospitals with high mortality than it was in the hospitals with low mortality. Now, does everybody get the joke? I mean, so most of the mortality is presumably not from minor complications. It's from major complications. Yes? Okay. So now if you divide the hospitals into groups that have very low mortality and groups that have very high mortality, and then you look and say, oh, the mortality rate in the hospitals with high mortality is much higher than it is in the hospitals with low mortality, it's kind of a, wow. At any rate, I find this pretty funny. I don't know, probably a lot. Anyway, this is, they have there's some other subtleties to the analysis that I haven't completely digested, but I thought this was, this is a feature article in the New England Journal of Medicine. Okay. All right, and this is just more entertainment. These are some domain names. Will that be on the final.com? Will this be on the exam.com? Do I need to know this.com? Will I need to know that.com and nopartialcredit.com? I actually own all those and a bunch of other ones kind of like them. And this is the time of year when the joke happens. So I know that what you all want to know is what will be on the midterm, which I'm not quite prepared to say exactly, but I'll give you as much of a clue as I can. Partly I'm limited by the fact that I haven't finished writing it yet. But let me tell you what I'm doing. I'm starting with the practice exams that are there online, and I am editing them down, and I'm going through the chapters and pulling out exercises from the chapters and perhaps changing the data or changing the wording. So this exam is going to be like the exams that are online and like the exercises that are in the chapters. Okay? It is not so much like a homework problem. The homework problems tend to be harder, especially once we get to counting. There's no way that I could assign you a serious problem about counting like we have in the homework just because there wouldn't be time to do it. That would be the only problem on the exam. So the number of questions is going to be a little larger than it is on some of the practice midterms. That is because in talking about reasoning and fallacies, I'm doing about, I don't know, 4 or 6 questions that are basically true-false. It's sort of like, is this valid or invalid? Right? So those shouldn't take more than a few seconds each. So I think that we'll probably end up with about 30, 35 questions on the midterm. My goal in setting the amount of material that's on the midterm is for people to start leaving roughly 40 or 45 minutes into the hour and a half or hour and 20 minutes that's available for the midterm. So it's not supposed to be a time pressure test. That's not the goal. It's not a memorization test. That's one of the reasons for allowing you a page of notes front and back. It's really about figuring stuff out on the fly. There are some things that you need to be able to do, like eyeball the correlation coefficient. We've done a lot of guess the correlation coefficient kinds of things. Now, this is not going to be a subtle question like, is the correlation coefficient 0.1 or 0.2, right? It's going to be, is it 0, is it 0.5, is it 0.95? Right? It's going to be big differences. So, but you'll be asked to do it. Yes?
I don't mean to interrupt, but I can't say a lot. The one midterm that I looked at so far has a lot of questions that covers material on stuff that wasn't in the chapters.
Right. The midterms that are there online are from old semesters where I taught different material in different order. You should just pay attention to those questions that are about things that we have covered. We have covered means they're in the chapters that we've covered, not meaning I've necessarily spoken about it in lecture, because there are things that are in the chapters. If it's in the chapter, it's fair game. Okay. Other, yes?
I noticed there's some questions on like experiments.
That's later in the course, not yet. The question was, he said there are questions about experiments. Experiments are not in the chapters we've covered yet. So, yeah.
I'm not sure, but like there were about 3 practice midterm exams, and like do they all have answers, or because I think I saw like one sole version, and like I wasn't sure if the others should have answers.
They do.
They do.
Yep. Yes. You need, okay, so just a reminder. Actually, maybe I'll remind you this way. Whoops. Okay. Are there solved versions of the midterms online? There are, yes. One of them, there's only one of them where there's 2 versions of it, one of which doesn't have solutions, the other does. The other ones are all self-answering. They all have the solutions built in. Yeah. Other questions? Shall I read this out loud? Everybody can read it? Okay. You need to bring a Scantron form. You need to bring photo ID. Photo ID is important. We will not accept your exam without looking at your photo ID. Bring a pencil. Useful. If you bring some extra Scantron forms, you might have a chance to make a few bucks by auctioning them off to the people who didn't bring them. Yes?
For these 30 to 35 questions on the midterm, do you like divide them like equally from the chapters, or you focus more on certain chapters?
I don't know yet. So the question is how concentrated are the questions on particular chapters? I think that, I mean, at the moment, it could end up that a lot of the questions are about the chapter on reasoning and fallacies, because those are just very quick true-false kinds of questions. There will definitely be, look at the residual plot. What can you say about the regression? There's definitely eyeball the correlation coefficient. There will almost certainly be questions that ask you to figure out how high to make the bin in a histogram based on the list of data, kind of things that were in the chapter on constructing histograms, et cetera. Questions about the mean, median, and mode, ask you to calculate a percentile, quartile, interquartile range. All those things, you ought to be prepared to calculate them. I think they will all be on the exam. They are all currently in my working draft, but I might end up cutting something. So I'm not going to, I can't commit exactly. Sorry? Tell us everything? I'm doing my best.
Those that you mentioned, those covers everything.
That covers everything. Yeah. I mean, it's. Well, that's kind of the goal, is to cover everything in some, level of detail. Yeah.
Out of curiosity, how well do people usually do on the midterm versus like the final?
People. So the question is, how well do people tend to do on the midterm and the final? It always surprises me that I say it's going to be like the practice exam, and then some fraction of the students either don't study or say, he must be trying to psych us out, let's study everything but what's on the practice exam. So some people manage to do badly, no matter what I do. But generally, people do pretty well. The grades on the homework tend to be higher than the grades on the exam, I think partly because you get 5 tries at the homework and you get 1 try at the exam. But historically, I've given out a lot of, the exam's easier. The exam is like the questions in the chapter. The exam is not as hard as the homework. It can't be. There's only an hour and 20 minutes to do the midterm, right? How hard can it be? Yeah. So I study. I mean, it's like, go through and do the practice, do the in-chapter exercises, and you will be fine. Work the practice exam, do the in-chapter exercises, you'll be fine. Other questions? Yes?
Will there be poker on the exam?
Will there be poker on the exam? Oh, worse than that. I'm going to make up some funky deck of cards that doesn't have 4 suits and stuff like that. Yes, there's going to be something in that direction. I haven't made up the problem yet, but I have in mind to make one up. Yeah. So
Each question is worth the same amount.
they're all worth the same. It's multiple choice. There's no weighting. So those true-false questions that are going to take you 5 seconds are worth the same amount as the poker hand. Yeah. Yes.
Should I know the rule about poker to solve
The rules about poker?
like crash, straight?
Well, you at this point, having seen all the poker hands, et cetera, I would expect you to know that there's 4 suits, there's 13 cards of each kind, and if I say, no, here's a deck that has 5 suits or 7 suits or something like that, you ought to be able to then figure out what's going on. But yeah, you don't need to know what beats what. I'll tell you if you need to know that. Question?
Do you happen to remember the names of fallacy, like appeal to force, and all those names?
You should be able to look at an art. I mean, because it's multiple choice, right? But you will be prompted with the name, right? And if you give it an example of like, give me your lunch money or I'll beat you up, you ought to be able to say, oh, that's an appeal to force. So, yes.
I have 2 questions. Are there going to be questions about like select all that apply? Like there will be one answer?
No, it's a Scantron. So the question is, are there select all that apply questions? There can't literally be because it's a Scantron exam and there can only be one correct answer. However, I could do, we were talking about this before, I could do what they do in the MCAT, which is something like, there's I, there's I, there's I, and then A is I and I, but not I, and B is, right? But I'm not planning to do that, but I mean, that's a way to take like true-false questions and combine them into something that's more difficult so that it deserves the same weight as other questions. But I'm not planning to do that. Everybody loves it so much. So, yeah. Yes?
And then for fallacy questions, each fallacy is going to only have
One best answer, yeah, because there isn't a select all that apply. The question was, for the fallacy questions, there's only one type. You categorize it one way, so it should be fairly unambiguous. At the moment, there's only one question like that as well. There's a handful of questions that are asking, if A, then B, A, therefore B. Is that valid or fallacious? Yeah. That's a valid argument, right? If A, then B, B, therefore A. That's not valid, right? Okay. You don't need to know what fallacy that is. You simply need to know whether it's valid or fallacious.
Are those questions more along the lines of using A and B and C, or are you using phrases in those, like if it's sunny, you're wearing sandals? Or...
There's likely to be some of each.
Okay.
Yeah. Yes.
Do you give us points if we, for guessing, like we got it wrong to subtract,
You-
like what are points off?
One point for everything right. Yeah, the question is, do I count off for guessing? Is there a different penalty for leaving the answer blank than for guessing something? And the answer is no, there's no penalty. And if you can, so typical test-taking strategy, right? Never leave anything blank. You might as well guess, right? And beyond that, if you can rule out 2 or 3 of the answers, then you can really, in some sense, improve your odds, right? So nonetheless, it is a rare year where someone does not score less than 20% on a multiple choice test. Actually do worse than you would get by random guessing. It's a miracle. Right? Other questions? Yes.
It doesn't sound like it, but are we going to have to know by terminology a fallacy of how A.
Fallacies of evidence. Okay. I'm not planning to ask things that way. Yeah. That's the cocktail conversation part of the class. Yeah. Huh. Shall we actually talk about content, or we just want to talk about the exam in a meta way? Okay, does anyone have any questions about anything in particular before we get going?
This may be off topic. How much reading chapter 11 will help me in this logic is A, then B, therefore not C?
Chapter 11 is propositional logic. The question is, how much will reading Chapter 11 help with the questions that are about Chapter 2? And the answer is probably some. I mean, there's definitely overlap between the material. So reading ahead to Chapter 11 will only reinforce the stuff we did in Chapter 2. Chapter 11 on propositional logic is not talking about informal fallacies. It is talking about validity and soundness, though, things like that. Much more mathematical detail on the logic there. Yes?
Can you go over in which situations you would need to subtract something from anything during counting?
Sure.
Full houses where you get 4 to the fifth, and you subtract 4.
Yeah, one sec. Let me just close this so I'm not bellowing into the hallway. All right, so when you're counting things, the question is, when you're counting things, how do you know when you need to subtract something? And the answer is, we have this handful of basic strategies for counting. One of them is, if you can represent something as a sequence of choices where the number of choices available to you at a given stage doesn't depend on what choice you made at previous stages, then you can use the fundamental rule of counting, which is a very powerful tool. Another basic tool for counting is sort of divide and conquer. If you want to count some big group of things and it's difficult to conceive of how to do that, you can subdivide it, count the pieces, and add the counts to get the total number. Another strategy for counting is to count a set that's too big, that includes more than you want to include, and then subtract off the extras that you counted. And that's what we're talking about. That's when you subtract. So we'll talk about, we can do that card hand example again to see why it comes up there. A different strategy is to count something too many times and then divide by the number of times you overcounted it, right? Divide by the number of times you counted it. And that's kind of what happened in the DNA problem and some other stuff as well. There we counted some of the strand, the 4 to the n calculation of the number of sequences counted some actual chemical compounds too many times, counted some of them twice because it counted them once this way and once this way, and it's the same piece of stuff. So, but in this cartoon of what DNA is like. All right, shall I do an example of that? Okay. So an example where that comes up is in calculating the probability of, or the number of straights there are. in a hand. So to remember, a straight is 5 cards in sequence, like ace 2, 3, 4, 5, 5, 6, 7, 8, 9. Okay, but if all 5 cards have the same suit, that's not a straight, it's a straight flush, which is a better hand. It beats a straight. Okay, so how do we figure out how many straights there are? And just to make this entertaining, why don't we calculate the number of straights there are in a hypothetical deck of cards that has 5 suits: spades, hearts, diamonds, clubs, and clovers. Okay, so we have this new deck of cards. It has, instead of 52 cards in it, it has an extra 13, so it has 65 cards in it. And we want to say, what's the probability? The cards are still ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. There's still 13 cards of each suit, but now there's 5 suits. And we want to know how many different ways are there to get a straight from a deck of 65 cards like that. We want 5 cards in sequence, but they can't all be of the same suit. If they are all of the same suit, then we have a straight flush, which is a different hand. It's a better hand. So let's write down a particular example of a straight and then generalize that to see what other choices we might have made. So we could have a straight that looks like 3 of spades, 4 of clovers. I don't know how to write that. Clovers, 5 of diamonds, 6 of diamonds, 7 of spades. 3, 4, 5, 6, 7. That looks like 5 cards. Okay. The problem is C is clubs and C is clovers, so I wasn't sure what to do. All right. So there's a particular example of a straight in this funny deck. Now, what could we have done differently and still ended up with a straight? We could have picked different suits for the cards, for instance, right? So instead of the 4 of spades, we could have had the 4 of diamonds. And instead of the 4 of clovers, we could have had the 4 of diamonds. And instead of the 5 of diamonds, we might have had the 5 of hearts. And instead of the 6 of diamonds, we might have had the 6 of hearts, and et cetera. Okay? How many different things could I have done and still ended up with a straight? Well, there are 5 suits to choose from in this funny deck, right? So there's a total of 5 suits, like 5 different 3s I could have picked. There's 5 different 4s I could have picked, 5 different 5s, et cetera. Okay? So if I multiply that out, that's 5 to the 5th possibilities. But some of those possibilities would have given me a straight flush, not a straight. Right? So if I count 5 times 5 times 5 times 5 times 5, I've counted a set that is bigger than the set that I want. I need to subtract off the extra stuff. Okay? So it is going to be easier to count something too big and subtract off the extras than to work out how many things there are in this set subject to the restriction that all 5 can't be the same. So the easier strategy for counting this is count something too big and subtract off the bits you don't want. So what are the bits we don't want? So if we took 5 times 5 times 5 times 5 times 5, that's 5 to the 5th. Now that's counted too much. How many sequences of suits, how many choices of suits for the 5 cards are in there that we needed to avoid in order to avoid having a straight flush? 5, right? It could have been, what are the 5? All 5 of them are spades, all 5 of them are hearts, all 5 of them are clubs, all 5 of them are diamonds, or all 5 of them are clovers, right? That's just 5 ways of specifying the 5 suits. So how many ways could we have done this and ended up with a straight but not a straight flush? It's 5 to the 5th minus 5, right? That counted a little bit too much. This is how many extras there are that we need to subtract off. So we could have chosen the suits of these 5 cards in 5 to the 5th minus 5 ways. But that's not the only thing we could have done differently and still ended up with a straight. What else could we have done differently? Yeah, so so instead of starting the straight on the 3, we could have had 4, 5, 6, 7, 8. We could have had 10, Jack, Queen, King, Ace. Okay, how many different ways can you get 5 cards in a row? 7, 8, 9, 10, 10. It's an integer. We're sure of that.
Can you count A and ace? Is it like low end and high end?
Let's say that aces can be used low or high. Okay, 10, right? You can have ace 2, 3, 4, 5, 2, 3, 4, 5, 6, on up to 10, Jack, Queen, King, Ace, right? So there's 10 possible starting cards for the straight. 1, 2, 3, on up to 10, right? I actually have trouble with it. Like, how many numbers are there between 1 and 11? Is that 10? Is that 11? Is that it's like sometimes it's just a hard thing to get. The end point is a problem. Okay, there are 10 different starting cards we could have used. So the total number of ways there are of getting a straight from this funny deck of cards without getting a straight flush, just a straight, is just this times 10. Right? Sorry?
I said, oh, that's it?
That's it. That's it. Well, I mean, there's nothing else we get to specify, right? What do we get to pick? We get to pick the starting card. Once you've picked the starting card, the other 4 faces are determined, right? You don't get to pick. If I pick that the 3 is the lowest card, there's nothing else to pick. The other 4 cards have to be 4, 5, 6, 7, 8. 4, 5, 6, 7. How about? Okay, so I could have said, oh, I'm going to specify the top card. Okay, if I specify the top card, what are my choices? They could be 5, 6, 7, 8, 9, 10, Jack, Queen, King, Ace. It's still going to be 10. Right? I get to pick one card, and having picked the one card, everything else is determined. I can pick the top card, I can pick the bottom card, I can pick the middle card, but some rule. Yes?
If we didn't have the clover, would the 5 to the 5th power, which one would be for the x one or the actual number?
Well, this 5 is saying I have 5 choices of the suit for the first card, 5 choices for the second card, 5 for the third, fourth, and fifth. So this 5 is coming from the number of cards. There, I have this 5 is coming from the number of suits.
4 to the 5th minus 4.
Exactly. Yeah. So for a standard deck of playing cards, I'd have 4 choices for the suit of each of the cards in the hand, but 4 of those. 4 of this number would correspond to all cards being the same suit. And so I need to subtract that off. I would have overcounted. We all together on this?
Yeah.
Yes.
What would happen if you made each number a specific suit? So like each number was assigned like instead of having 2 diamonds, say you would have spade, clover, diamond, and whatever.
Oh, so if you want to ask how many hands are there where, okay, so I think you're asking a different question. Suppose that we wanted to have, we're making up a new kind of hand, which is that you need 5 cards in a row, and the suits of those 5 cards all have to be different. That's the question? Okay, so this is a new game that we're playing with our new deck of cards, where we have this thing called, I don't know, an elate. Right, and in an elate, it's kind of like a straight, except that all the suits have to be different.
You need 1 club,
You're right. Okay, so we've got 3 of spades, 4 of clovers, 5 of hearts, 6 of diamonds, 7 of clubs. So we've got 5 different suits. Okay, so I still get 10 choices of the starting card, right? Okay, so there's 10 ways of doing that. Now, what do I get to pick among the suits?
You don't have enough time.
Okay, so one question is, this is not, a question is, here's the answer, yes. This is a different hand from 3 of clubs, 4 of clovers, 5 of hearts, 6 of diamonds, 7 of spades. Right, those are 2 different elate hands. right? Because this assignment of suits is different. It's the same 5 suits, but the same cards don't have those 5 suits. The suits are distributed in a different way. Right? How many ways are there of assigning one of the 5 suits to each of the 5 cards? 5 factorial, right? It's just how many different orders you can put those 5 suits in. Does that make sense? I could go spades, clovers, hearts, diamonds, clubs. I could go clubs, clovers, hearts, diamonds, spades. I could go spades, clovers, diamonds, hearts, right? There's 5 factorial different orderings of those 5 things. So this is just 10 times 5 factorial. Are we good? Excuse me, questions? No. We've already said they have to have these 5 different suits. And the only question is, which card gets which of those 5 suits? Right? So we've already said there have to be 5. There's just 5 factorial different ways of ordering those 5 different suits. Does that make sense? We're not overcounting anything. We don't need to subtract anything because we haven't counted anything extra. You're not happy, I can tell. Okay, so let's figure out what.
Well, one of the. Sorry, never mind. You might answer the question.
I might answer the question accidentally. Yes, could happen.
So I was wondering, what about like flush with same suit? Once you overcome, are you counting those as well?
Okay, let me see if I can satisfy your question, and then we'll go on to the next one. So we're really just, once we pick the starting card, all that's left to do is list what order the suits are going to be in for the 5 cards, starting with the smallest. So here we can think of this as happening in 2 stages. That first, we're picking a starting card. We pick the starting card to be 3. That now determines that the cards in the hand are going to be 3, 4, 5, 6, 7. Okay, what's left to do is to say, we've got these 4 suits, spades, hearts, diamonds, clubs, and clovers. And we need to know which goes with which. Because they have to be these 5. Right? And it's only 1 to 1. We don't get to assign 2 suits to 1 card or 1 suit to 2 cards, right? It's just 1 to 1. So we really just need to know, do these go like this, etc., or do they go like this? How do they go? Well, really, that's one way of saying that is simply, let's say that the first suit that we list goes with the smallest card, the second goes with the second smallest, etc. So if we put these in some order, that corresponds to assigning a suit to the 3, assigning a suit to the 4, etc. So here's one order. That corresponds to 3 of spades, 4 of hearts, 5 of diamonds, 6 of clubs, 7 of clovers. Or I could instead take these 5 things, these 5 suits, and put them in a different order. I could go hearts, spades, diamonds, clubs, clovers. Okay, and that would correspond to 3 of hearts, 4. Okay, how many different orders can I put these in so that the first one goes with the 3, the second one goes with the 4, etc.? There's 5 things. They can be in 5 factorial orders. Is that okay? Sorry, there was a question over here. Or did I?
I think you kind of answered it, because I was wondering, what about overcounting the one with the same suit, like 3 of spades, 4 of spades?
Well, the 3 of spades can happen. So the question is, aren't we overcounting the same suit? Well, having said that the 3 gets the spades, we still have 4 factorial different ways of assigning the other 4 suits to the other 4 cards. So 3 of spades will happen many, many, many times among these elate hands, right? Because it'll happen with the other ones in the order hearts, diamonds, clubs, clovers. It'll happen with the other ones in the order clover, club, diamond, heart, etc. It'll happen many, many times. But each time, we are getting 1 suit for each card, and those suits are all different. So we're counting the right number of things. There's a question. Yes?
I was going to say another way to think about it is that you have, like when we did the CD example in the songs, you said you have, well, for this example, it would be you have 5 choices for your first card. And when you pick that one, for your next card, you've only got 4 choices left.
Yep.
But for your next one, you only have 3 choices.
Okay, so that might be an easier way for many people to think about it. So I picked that we have 3, 4, 5, 6, 7. What suits can the 3 get? We have 5 choices for the suit that gets assigned to the 3. Spades, hearts, diamonds, clubs, clovers. Having assigned this one a suit, we now have 4 choices left for the suit that goes with this one. Having assigned the suit to these 2, there's 3 choices left for that. Having assigned the suit to that, there's 2 choices left for that, and there's only 1 left here. That's 5 times 4 times 3 times 1. That's where 5 factorial comes from. It's using the fundamental rule of counting to do this allocation. We get to pick this 5 ways. No matter what we do there, we have 4 choices left. No matter what we do on the first 2, we have 3 choices left, etc. Yes?
Can you review the difference between 5 factorial combination and permutation?
Sure. The question is, can I review the difference between factorials, combinations, and permutations and stuff? Okay. 5 factorial, I mean, numerically, n factorial is, n times n minus 1 times, et cetera, times 1, right, down to 1. Okay? What is, among the things this represents, it represents the number of ways there are of taking n distinguishable objects and putting them into some order. So I could take n people from the room. I can tell everybody apart, right? You're distinguishable objects. So we can say you're first, you're second, you're third, or you're first, you're second, you're third, right? You can tell those orderings apart. So I have n choices for who goes first. Having put somebody first, there's n minus 1 choices left for who goes second, et cetera, et cetera. Since it doesn't matter who I put first, I still have n minus 1 choices for who goes second. I can multiply these things by the fundamental rule of counting to figure out how many ways there are of doing this in all. Now, who's left after I put somebody first depends on who I put first. But the number of people left doesn't depend on who I put first. That's what's crucial to the fundamental rule of counting. Now, suppose that I have n people, and let's be a little bit more concrete. Let's suppose that I have 10 people. Sorry, n equals 10. And I want to put 5 of them into some order. How many ways are there of taking 5 of the 10 and putting them into some order? Well, I have 10 choices for the first person, 9 for the second, 8, 7, 6, right? And then I stop. I now have 5 people in order. Okay? So this is 10p5. Okay? It's the number of ways there are of putting 5 of 10 objects into some order. What is it in terms of, in terms of symbols, there is a sort of compact way of writing this, because this 10 times 9, 8, 7, 6, we could also write as 10 times 9 times 8 times 7 times 6 times 5 times 4, 3, 2, 1, divided by 5, 4, 3, 2, 1, right? Because those would cancel. So this is 10 factorial divided by 5 factorial. So that's just a shorthand way of calculating this. I mean, it's not even a good way to calculate it numerically, because the numerator is unnecessarily large. You get into numerical issues with that, right? It's better to calculate it this way, but algebraically, these expressions are identical. They're as a theoretical matter, they're equal. Point of view of calculating them, they're not as easy. They're not equally easy. Okay, now suppose that instead of wanting to put 5 people into some order, I just wanted to get a group of 5 people out of the 10. I don't care what order they're in. I just want 5 people. You're going to be a committee. We're going to go off and have a cup of coffee together. How many ways are there of picking 5 people to go have an espresso with out of the 10? Right? Well, this is the number of ways there are of picking 5 people in some order. But if all I care about is the set, not the order in which the people are in, the order in which they're in, right? Then this number overcounts, right? This counts each set of 5 people a whole bunch of times, right? So we can use this other strategy for how do you count something? Well, you count everything too many times, and then you divide by the number of times you overcounted. Well, how many times did I overcount a particular collection of 5 people? Well, I counted those 5 people once with somebody in first place, second, third, fourth, fifth, and then I counted it again with these 2 interchanged. I counted it again with these 2 interchanged. I counted them in a bunch of different orders as if they were different groups, but they're not. They're one and the same group. Well, how many different orders does that one group of 5 people appear in this enumeration? 5 factorial, right? Because if I have a particular set of 5 people, I can put them into 5 factorial different orders. Each of those is getting counted separately in here because I'm counting permutations. So I've overcounted every set of 5 people 5 factorial times. Excuse me. So if I want to know how many sets there are, it would be 10, 9, 8, 7, 6 divided by 5, 4, 3, 2, 1. And that's 10, choose 5. And that's equal to 10 factorial over 5 factorial times, we'll write it as 10 minus 5 factorial. They're both, 10 minus 5 happens to be 5. I picked a bad example numerically because you don't know which 5 I'm talking about when I say 5. So why don't we make this, instead of, let's make this, we choose 6 people or make it 11 people we're picking from, or what do you want to vary?
11 people, you just have to stick with 11. Oh, well then.
Okay, but then I'm picking, so I can make this 11. This is now, that now stops there. This would be 11 P5. Okay, I have 11 choices for the first, 10 for the second, 9, 8, 7. And this would be equal to what? 11 factorial divided by what's getting divided out? 6 factorial. Okay, so what this is if I'm taking NPK, then what this is this is n factorial over n minus k factorial. Right, is NPK. Number of permutations of k of n things. Yes?
So because it's a multiple choice exam, would you give us like an accounting problem? I see in the practice exams it's just 11P5 or 10C5. You're using that notation. Would you ever use the n factorial over n minus k factorial to test our understanding of like the algebra?
The question is, would I ever use symbols like factorials or whatnot? I might possibly, what I'm more likely to do is to give something that involves specific numbers and sort of say 130. Is that it? Yeah. Okay, so then this is, if we want to make this 11 choose 5, then we would have 11, and this is now 6 times 5 times 4 times 3, and that is 11 factorial over 5 factorial times 6 factorial, right?
So it's n factorial over k factorial times n minus k factorial.
Exactly. So the general form for n choose k is, where should I go here? So this is the number of sets of k things we can form from a population of n things.
Is it okay if you talk about trends in association with the graphs?
Trends in association with the graph, sure. All right, so yeah, a really common question is, how do I tell if the residual plot has a trend? That people are somehow very confused about what it means to have a trend. Let me try to talk about that. Are we all right to move on from combinations and permutations and this sort of thing? Okay. There's a residual plot. Does that residual plot have a trend? No. Okay, why not? What are you eyeballing? How are you judging this? Okay, if I were, one way to think about it is what is the correlation of the residuals and the horizontal axis? What would the correlation coefficient for this scatter plot be? 0, right? If I did my best job to fit a horizontal line to this, to fit a line to this, the line would be horizontal. It would be something like that. Okay? So there is no trend in these residuals. But what if it looked like this instead? Now there's a trend, right? Generally, the values on the right are higher than the values on the left. If I fit a line to this, the line would do something like that. Okay? So that would show a trend as a residual plot. Yes?
So basically, if R would be 0, it's not a trend.
Yeah, exactly. The trend is 0 if the correlation coefficient for the residuals would be 0. If the correlation coefficient for the residuals is anything other than 0, there's a trend. That's it. Yep.
So if you have your no trend parabola that like it's above the x-axis, is that still, that's obviously still no trend? Then the problem would be what the calculation.
Okay, so this, as a residual plot, wouldn't exhibit a trend, but we have a problem in that the mean of the residuals is something like this. And the mean of the residuals ought to be 0 if we calculated the regression correctly. So a residual plot that looks like this would indicate that something went wrong in calculating the regression line. There was an algebraic mistake. Okay? The two things that flag an algebraic mistake in calculating the regression line are that the mean of the vertical residuals isn't 0, or that there's a trend in the residuals. Now, without going into the mathematics of the projection theorem or something like that, when you fit a line, you are getting a constant and a slope, right? You're getting these sort of two components. So the constant that is left over after you subtract the line ought to be 0 because the line is supposed to subtract all of the constant that there is. So if your residuals don't average to 0, the vertical residuals don't average to 0, you didn't subtract the right constant. The constant in the line is wrong. Similarly, what is the slope supposed to do? Well, it's supposed to account for the data as well as possible by slope. So what's left over when you're done shouldn't have any slope, right? So if you have a trend in the residuals, then that means you calculated the slope incorrectly, the regression line. So it's sort of the two things. The constant takes out as much as any constant can, and then the slope of the regression line is supposed to take out as much as any slope can. So what's left should have no constant and no slope. And if it has constant or slope, then you did it wrong. So, but slope here means trend, linear. Yes?
Does the point of averages have to be on the origin or just on the x-axis?
No, it's the vertical residuals that need to average to 0, not the horizontal ones. The horizontal ones are, there's not a horizontal residual. This is just whatever the x values happen to be. If my measurements are all 1 million to 10 million, I'm not changing the values of x when I subtract the regression line. The values of x are still 1 million to 10 million, but the values of y, once I have, those ought to average to 0. Yes?
Using this graph, can you talk about the RMS error?
Sure. So the question is, can I use this graph to talk about the RMS error of regression? So all right, this is a bad example because the regression line was calculated incorrectly. If we want to talk about this as the data rather than as the residuals, then we can go ahead. Otherwise, I'd like to draw a residual plot that corresponds to having done regression correctly. So let me redraw that. So let's say that I did regression and my residuals now look like this. Okay, they're scattered. The vertical mean of the residuals ought to be 0. Okay, horizontal mean is whatever the data were. That doesn't change by doing regression. What is the RMS error of regression? Well, what I'm doing is I'm taking each little residual. I'm taking, so that is the residual, right? When we subtract the regression line, so what I'm plotting is the difference between the y value of the data and the y value predicted by the line, the y value for the same value of x on the line. So there's one residual, there's another, there's another, there's another, there's another. What is the RMS error of regression? Well, I take all of these values, I square them, right? RMS, root mean square. Square them, take the mean of the squares, so I divide by how many there are, and then I take the square root of that. So the further these points are from the line, you know, if it looked like this instead, the RMS error of regression would be bigger. It's saying that the points on average are further from the line than in the previous figure that I had. So the RMS error of regression is measuring sort of on average how much does the regression line miss the data, right? If the RMS error of the regression were 0, that would mean that every single point was exactly on the regression line. That would only happen if the correlation coefficient is 1 or minus 1. Okay? Now, how can I get a numerical value for the RMS error of regression without mechanically going through, taking each value of y, subtracting the corresponding value of y on the regression line, squaring all those things, adding them up, dividing by how many there are, and taking the square root of the result? That's lengthy, right? So it's just an algebraic fact that if you do that, you get the same answer as taking square root of 1 minus r squared times the SD of y.
How do you draw the SD of y on that graph? Like, well, the graph that you just drew.
Well, I don't know what the SD of y is because this is a residual plot. So I don't know what the original plot would have looked like unless I know what the regression line was that was subtracted from the original data. So from the original, if we have the original plot and it looked something like, you know, this, for the sake of argument, then, you know, the SD of y is going to be something like that. Okay, I'm basically saying take all the y values, make a list of them, take their standard deviation. Okay, and that's a measure of how vertically scattered the plot is. The plot can have a lot of vertical scatter overall, and yet the vertical scatter around the regression line is really small, right? If a line fits the data well. In particular, in the extreme case, we can have all the data falling exactly on a line. So the SD of y is really, really big. The SD of the residuals is 0 because all the points fall on the line. Okay.
So in that formula you just put up, we use the standard deviation of the data, right? Not the residual.
Right, SD of y, the original, because we're basically finding the SD of the residuals. The larger the absolute value of the correlation coefficient, the stronger the linear association, the smaller the RMS of the residuals, the better job a line does of explaining the data. Right? Stronger the linear correlation, the closer the data are to falling on a line, so the smaller the RMS error of regression is. And that's reflected in the formula because we're looking at 1 minus r squared. Right? As r gets to be plus or minus 1, r squared gets to be plus 1, 1 minus r squared gets to be 0, this thing gets small. Yes?
So let's say you have a scatter plot of the data and you have only 2 points, and then it's like a horizontal line. So why is r in that case undefined instead of 0?
You're saying if you basically just have 2 points and they fall on a horizontal line?
Right, yeah.
Okay, what's the SD of y? 0. How do you calculate the correlation coefficient?
It's going to use the average of product of standard units.
Okay, so average product of standard units. Okay, how do you convert to standard units?
Data minus the mean divided by standard deviation.
Okay, so if the SD of y is, so the way you go to standard units is data value minus the mean of that list divided by the SD of that list. So if the SD of that list is 0, you have a divide by 0 issue. That's why it's not defined. Okay. Yes?
Can you explain how to do one of those problems where there's like the wife and husband and you need to find how many are in between like the different range for both?
You're talking about like percentiles of like the...
Like, you need to find, like that you're giving the mean and the SD for both like the wife and husband income, and then you need to know like how many like wives are in between this and husbands are in between this.
So there's, I'm trying to... Double Chebyshev? Yeah. Ah, okay, sure, yeah. Okay, there's one kind of problem on, I think, one of the midterms that you should just ignore, which asks about, like, consider husbands whose IQs are in this range. What would you estimate the 84th percentile of wives' IQs to be? That's relying on something that we didn't do. So that's sort of estimating percentiles in a slice through a scatter plot we didn't do. We're not going to do it. Okay, this other, the double Chebyshev thing, I mean, this isn't really right, why do I do it? I mean, I really do it to try to get your thinking about something to be really crisp. And it's just like to really see what's going on. So let me talk through that again. By the way, it's in the book. I think if you might need to expand a footnote, but it's done in detail in that chapter. All right, so we have a scatter plot. We don't really know anything about it except that this is the point of averages, and we know what the vertical SD is, and we know what the horizontal SD is. Okay, so what I'm drawing here is plus or minus 1 standard deviation of the horizontal variable, plus or minus 1 standard deviation of the vertical variable. And now I might ask, what fraction of the points are in a box that is, say, plus or minus 2 standard deviations in this direction, and let's make it plus or minus 3 standard deviations in this direction. I'm not going to be able to sketch it that way. So the idea here is that this is 3SDY, 3SDY, and this is supposed to be 2SDX, 2SDX. Okay? And I'm asking what fraction of the points must be in this larger box. There's a limit on how many, there's a bound on the fraction of points that can be outside here. And how can we calculate that? Well, if we look just at the x values, Chebyshev's inequality says that the fraction of points that have an x coordinate that is more than 2 standard deviations away from the mean of the x values is at most 1 over 2 squared. So at most, a quarter of the points have x coordinates that are outside this range. So Chebyshev says that this fraction, the fraction that are more than at least k standard deviations from the mean, is at most 1 over k squared. Can you guys read my handwriting? I can't read my handwriting, but maybe you can. Yeah. Okay, so the fraction that have x coordinates more than 2 standard deviations away from the mean of x is at most 1 over 2 squared, which is a quarter. And the fraction that have y coordinates that are more than 3 standard deviations of y from the mean of y is at most 1 over 3 squared, at most a ninth. So if we throw out all that, we're throwing away at most a quarter of the data. And if we throw away all that, we're throwing away at most a ninth of the data. So what's left in the middle has to be at least 1 minus a quarter minus a ninth. Okay, so what's left in here has to be at least 1 minus 1/4 minus 1/9. Now, the temptation that people have is to think, okay, I've thrown away at most 1/4 of the points here, and then when I go in this direction, I'm throwing away at most 1/9 of what's left. And they do a calculation that looks like that looks like 1 minus 1/4 times 1 minus 1/9 instead of 1 minus 1/4 minus 1/9. I don't know if I'm making sense. The temptation people have is to somehow say that sorry? I'll see if I can make it clear. They're actually taking away a little bit too little, but they're sort of like, okay, there's got to be 75% of the values in here, and then a ninth is like 11%, so this is like 89%. Is 1 minus a ninth is about 89%, give or take? Okay, so say I've got at least 75% of the points left after I throw that away, and then I have at least 89% of what's left when I throw that away, which would be a number, so that's looking like taking 1 minus 1/4 times 1 minus 1/9. Okay, what's wrong with that? They're different numbers, right?
So that the one up there is wrong?
It's wrong.
So 1 minus 1/4 minus 1/9 is correct?
Yes.
Because the top one, when you subtract the fourth, some of those points included in that quarter are also included in the 1/9.
Okay.
Because when you do it separately, the second part of that top equation, the one on the left, includes some of the ones that were supposed to be gone in the quarter.
Okay, so there are indeed some points that you are ruling out twice. Once because they're out this way, and once because they're out this way. The question is, what fraction of the points are getting ruled out by both rules rather than just by one? And the answer to that is you can't tell. And this assumes that it's a proportional number. This assumes that of the ones that are ruled out because they're this, you're ruling out at most 25% of the points. You're also ruling out at most 25%. It's assuming that things are proportional and there's no reason for them to be. Let me explain it a different way. Once I've thrown out these points, what can I say about the standard deviation of the y values of the points that are left? Do I know anything about it at all? No. Okay, if I knew that the standard deviation of the y values wasn't changed, things would be very different. All I know is when I'm throwing away things that are more than 3 standard deviations of y for the original list. Okay, so I can't sort of apply Chebyshev's inequality separately in this direction to the remaining points. I don't know what their SD is. Right? I would need to put their SD in. I don't know their SD. I only know the SD for the original list. I don't know the SD of what's left. This is not helping. At the frustrated looks, and it's like, this is, I mean, what I would like you to get out of this is two things, right? One is I'm throwing away at most 1/4. I'm throwing away at most 1/9. So I'm throwing away at most 1/4 plus 1/9, right? That's what this does. Second thing I'd like you to get is that this calculation assumes more than you have. Right? You don't have the information you would need to justify this, because this is saying you're throwing away at most 1/4, and then you're throwing away at most 1/9 of what's left. How do you know what you're throwing away of what's left? You would need to know something about its SD. You don't know its SD. Okay? Okay. Good, okay. Yes.
So after
Mm-hmm.
The 1/9, we're not sure that the SD of the other direction is 1/9. Is that what?
We don't know what the SD is of the y values that are left after you throw away the points that have the other x values. Yeah. Okay. You know you're throwing away at most a ninth of the original. You don't know whether you're throwing away at most a ninth of what's left. That's the short version. Okay. Other questions? Yes?
Can you explain how the argument can be sound and valid, or valid and sound?
Valid and sound or valid and unsound? Both. Okay. All right. So validity and soundness. All right. So validity has to do with the argument as a piece of mathematics. Is the logic correct? Right? Is it, so it's a caricature, but like let's say for the sake of argument that if you weigh 100 pounds and I weigh 155 pounds, then together we weigh 255 pounds. Okay, that's valid. Now, if you don't weigh 100 pounds and I don't weigh 155 pounds, then it's not sound. I mean, it's sort of the argument. An argument is valid if the conclusions follow from the premises on the assumption the premises are true. If, in fact, the premises really are true, then the argument is sound as well. So you can't be sound without being valid, but you can be valid without being sound. An argument can be valid without being sound. The argument is valid if it's a correct piece of mathematics, even if its assumptions are false. But it's sound if it's a valid piece of mathematics and its assumptions are, in fact, true in the real world. Okay, let me put a better example. So it's like, let's we have a hypothesis that says, if you study the practice midterms, then you will make an A on the midterm. You study the practice midterms, therefore you will make an A on the midterm. Okay, that's a valid argument. If the assumption is true that if you study you'll make an A, and the other assumption is true that you study, then it is true that you will make an A. Okay, but if either it is not true that studying will guarantee you an A, or you don't study, then that argument, while it's valid, isn't sound because its assumptions aren't in fact true. So it's got to do with, the validity has to do with on the assumption that the assumptions are true. This sounds odd. Then on the assumption the premises are true, at least they were using two different words. If the premises are true, the conclusion follows. That's validity. Premises are true, conclusion follows, that's validity. Plus, premises are in fact true in the world, that's soundness. Okay?
So saying the weight, that was not sound because you don't actually know the weights?
Well, it would be sound if she weighs 100 and I weigh 155. If I'm just being really optimistic.
But even if 100 plus 100 is not equal to 255, that still doesn't mean it's sound. You're not looking at
No, that's valid, but not sound.
Valid regardless of
Valid regardless of what I weigh.
because the math is correct.
Because the math is correct. Validity is really just, is the math right?
But it would be sound if the weights were actually.
If that really is my weight and that really is her weight. Yeah. So the premises are true. Yeah. Yes.
So I guess on the midterm, we're not going to get questions that are. I mean, some sound arguments can be more subjective. So are we on the midterm? Are we going to get ones that are more clear, like the sun is green versus weight? Like we would probably get one like.
If Homer Simpson is an alien, then the sun goes around the Earth. Yes. Right. Okay. Yeah. I'll.
It'll be.
Homer Simpson is an alien, therefore the sun goes around the Earth. Okay, except not. Right. Other questions? Part of the room I haven't heard from. Anybody back there? All right. Just when you're calculating, let's say, a percentile of a list of numbers, what's a really good first step? sorting the numbers. I highly recommend sorting the numbers before you calculate percentiles. Okay? If I have a list that has an odd number of numbers in it, what is the median of the list? Odd. Odd. Okay, it would be the middle number. If it's an even number of numbers in the list, it's the small, yeah, okay, so the definition is smallest number that's at least as big as half of the entries in the list. What is that going to be? It's going to be the 5th value out of 10, right? It's going to be the 10th value out of 20. It's going to be the 6th value out of 12, because that is the number that is at least as big as half. That is the smallest number that's at least as big as half of the numbers in the list. Okay. Sorry?
So if it's out of, if there are 10 numbers and say it's 50% that would be?
The 5th number, yeah. So it says 10 numbers, 50th percentile will be the 5th number. What is the 25th percentile of a list of 10 numbers? It would be the 3rd entry in the list after sorting it, right, from smallest. Got to sort it.
So if it's like the 50.2 percentile, it would be the 6th number.
Yep. For the 50.2 percentile, you have to go to the 6th number, because that would be the smallest number that is at least as big as 50.2%. It is, in fact, the smallest number that's at least as big as 60% also. But it's the smallest number that's at least as big as 50.2%. So you get these things in chunks, right? What are the units, if we have a histogram? What are the units of the vertical axis? Okay, remember, how does a histogram represent stuff? It is that the area of this bin is the fraction of observations that are in this range, with some convention about whether you include the boundary in the one to the left or the one to the right. Right? We need an endpoint convention. Right? So we might have our endpoint convention be that we include the left and exclude the right. And then this bin would include its left and exclude its right, et cetera. Okay, so the area of this bin is the fraction of observations that are in this range. All right? So if area is base times height, right, for rectangles. So the units of the base are the units of original measurement. This could be dollars, it could be, inches, it could be something like that, right? So when we multiply the base times the height, we get percent. What do the units of height have to be?
Percent per base.
Percent per whatever the units of the x-axis are, right? Just sort of a simple dimensional analysis. Percent per something times something is percent. Yep. Miles per hour times hours is miles. Yep. Okay. Yes? Yeah, so the question, if I ask you to construct a histogram, I will tell you what endpoint convention to use if there's borderline, if there's points on the boundaries. Skewness, modes, stuff like that. Everybody remember that stuff? Okay, help me sketch something that's skewed to the right, or maybe I have already. Okay, that's skewed to the right? The tail goes off along to the right. What kinds of things have right-skewed distributions?
House prices.
House prices, weights, incomes, most anything to do with money that is going to be skewed to the right. Salaries, tax bills. Okay. Is this unimodal, bimodal, trimodal? Unimodal, alamodal, yeah. Okay. This is unimodal. It has one bump, right? Okay. And skewed to the right. Okay. Give me an example of something that's skewed to the left.
Our exam scores from Tuesday.
That's probably true. He said the exam scores this coming Tuesday. Yes. They will likely be skewed to the left. Most people will do well, and some people will manage not to. Other questions? Let me take a quick look at what I have of the exam so that I can... Maybe yeah, forgive me for not like displaying the questions to you that I've already got written. Yeah. Okay. If the SD of a list is 0, what do you know about the numbers in the list? If the SD of a list is 0, what does that tell you about the list? They're all the same. Are they all 0? Not necessarily. Could be anything, but they're all the same. If the IQR of a list is 0, what do you know? In the middle 50% of the numbers are the same. Okay? At least 50% of the numbers are the same. Could be more than 50%, but at least 50%. Right? The middle 50.
Zero?
If the IQR is 0. Yep.
Then the middle 50 is 0, right?
Then the middle 50 is equal.
At least.
IQR is the upper quartile minus the lower quartile, right? So that is the IQR, it's an interquartile range. Is it actually a range? It's a number, right? It's a single number. It's the value of the 75th percentile minus the value of the 25th percentile. You take that difference, that gives you a number, right? That number could be 0, that number could be 47, whatever. Okay, so that number, the smaller that number is, the more concentrated the middle 50% of the data are, right? It's a measure of how spread out the values are, okay? The middle 50% of the values. What about the range? If the range is 0, what do you know about the list? They're all equal, right? Because the biggest one minus the smallest one is 0. There's no difference between the biggest and the smallest. There's no difference between the biggest and the smallest. There can't be any difference between any of the rest, right? They're squeezed between the biggest and the smallest. Okay. If the RMS of a list is 0, what do you know about the list? This isn't RMS of the residuals. This is the RMS of a list. They're all 0, right? What's the definition of the RMS of a list? Okay, root mean square. So you take the numbers and you square them all. Now, if they were negative, after you square them, they'd be positive. If they were bigger than 0, after you square them, they'd still be bigger than 0, right? Okay, you take those numbers, you average them, and you take the square root of the result. If you started with anything other than 0, after you square it, it's going to be positive. After you average it, it's still going to be positive. After you take the square root, it's still going to be positive, right? So the only way the RMS can be 0 is if all the numbers are 0. Median, can the median of a list be 0 without all the numbers being 0? Sure, yeah. It just means that 50% are no bigger than 0. Right? Doesn't tell you anything about how big the biggest ones get nor how small the smallest ones get. All right, what else do I have here to give away? Yeah, work the examples in the chapters. That's the best single thing you can do. Work the examples in the chapters. The practice problems. You're about to ask a question? No. Any other questions? Okay, I'm actually not going to be here next week. The exam is going to be administered by 2 of my PhD students. I'm at a conference on national security and extreme scale computing. So something, I don't know. All right, good luck. I'll see some of you at office hours.